Imagine staring at Jupiter and noticing something you were never told to look for: a massive dark scar, stretching thousands of kilometers across the planet's swirling clouds. It doesn't glow. It doesn't demand attention. And yet it's there, quietly slicing through the atmosphere like a shadow no one wants to acknowledge. And here's the unsettling part. Everything you think you know about Jupiter's legendary storm, the Great Red Spot, might only be half the story. Because behind that iconic crimson vortex lies a darker, quieter secret that has slipped past news headlines and press releases for years. Today, we peel back that silence. We follow the shadows, trace the hidden data, and uncover what NASA and the media never quite emphasized, not because it's sensational, but because it's complex, inconvenient, and deeply important. And if you stay with me, in Section 5 we'll reveal a brand new oscillation pattern, a rhythmic pulse inside Jupiter's storms that could rewrite everything we thought we understood about weather on gas giants. Jupiter is a world sculpted from gas and storms. A giant, so massive it could swallow more than 1,000 Earths without even noticing. Its atmosphere is a restless ocean of hydrogen and helium, threaded with drifting ice crystals and stacked with towering ammonia clouds that rise higher than any mountain on our planet. And through this churning chaos, one feature has captured human imagination for centuries: the Great Red Spot. First documented in the 19th century, this colossal storm has raged longer than entire civilizations have existed, spinning with winds far beyond anything Earth has ever experienced, and cementing itself as the most iconic landmark in the solar system's weather. But here's the part. Almost no one talks about behind the fame of the Great Red Spot lies something far more subtle. A darkened region, a shadowed layer of Jupiter's atmosphere that rarely makes its way into headlines. It isn't dramatic, it isn't photogenic, and perhaps that's exactly why it remains hidden. Yet this quiet darkness may hold clues about how Jupiter's storms truly behave, evolve, and decay over time. Why has this dark side of Jupiter's weather barely reached your newsfeed? The answer lies in next section. Most people hear the phrase Great Dark Spot and imagine a single, dramatic feature hiding somewhere on Jupiter. But the reality is far more nuanced. In planetary data, scientists have occasionally detected large, shadowed regions, including the intriguing Great Cold Spot high in Jupiter's thermosphere, a place where temperatures suddenly drop hundreds of degrees and form a vast, dark imprint against the surrounding gas. But, unlike the Great Red Spot, this term isn't an official name or a recognized storm. It's a loose label used by researchers and even the media to describe unusual dark patches that appear, drift, and disappear within Jupiter's turbulent atmosphere, and within the atmospheres of other gas giants. That is why the idea of a great dark spot carries both a scientific and symbolic weight. Scientifically, it points to real anomalies that hint at hidden dynamics beneath Jupiter's familiar cloud belts. Symbolically, it represents everything about Jupiter's weather that remains unspoken. The regions overshadowed by the famous red storm, the phenomena too subtle or too complex to make it into mainstream headlines, the quiet mysteries left in the dark. It is, in many ways, the part of Jupiter no one tells you to look for. And in Section 4, we will dive into new data that reveals something even veteran astronomers did not expect. 4 generations. The Great Red Spot has been treated as a permanent landmark on Jupiter, on a storm so ancient and so immense that many assumed it had raged unchanged for centuries. But in 2024, a new analysis suggested something far more surprising. According to researchers, the storm we see today might not be the same one first recorded in the 17th century. Instead, it may be a younger vortex that formed after the original giant storm faded away, meaning the Great Red Spot could be an imposter of its own legend. And the evidence continues to grow. Modern measurements show that the storm is now only about 8,700 miles wide, roughly 14,000 kilometers across. Older telescopic drawings from the past 200 years suggest it used to be nearly twice or even 3 times that size. It is shrinking, tightening, and evolving in ways no one expected. Then came the most intriguing discovery of all. Fresh data from the Hubble Space Telescope revealed that the shape of the Great Red Spot rhythmically swells and slims in a cycle of about 90 days, as if the storm itself were pulsing. Astronomers compared it to a bowl of gelatin gently wobbling after being tapped, except this wobble spans a structure large enough to engulf Earth whole. These oscillations were never part of the textbooks, never part of the popular narrative, and yet they may be the key to understanding the storm's slow transformation. And it leads to a startling question. What if the true dark spot on Jupiter is not a shadow we can see, but the slow disappearance of something we once believed would last forever? In section 6, that possibility becomes impossible to ignore for most people. The story of Jupiter begins and ends with the Great Red Spot because it is simple, iconic, and easy to visualize. That is exactly why the media gravitates toward it. A massive red storm is an irresistible headline. But the subtle changes happening inside that storm, the shrinking, the oscillations, the quiet pulses, are far more complex to explain. Planetary science itself is a specialized field with research buried inside academic journals, not crafted for viral articles or dramatic thumbnails. So while scientists debate 90-day oscillations or atmospheric anomalies, the public rarely sees more than a passing mention. There is another reason the darker side of Jupiter's weather remains unseen. Calling something a dark spot sounds dramatic, almost alarming, but describing the same phenomenon as changes in the storm's shape or fluctuations in its energy does not spark attention in the same way. And so these deeper truths slip between the cracks, overshadowed by the storm's famous red glow. Yet those quiet details may matter far more than the headlines suggest. And in section 5, we will dig into a controversial possibility, one that could force us to rethink everything we thought we understood about planetary weather. In 2024, a study led by Sanchez La Vega delivered a revelation that shook the foundations of everything we thought we knew about Jupiter's greatest storm. The researchers proposed that the Great Red Spot we see today may not be the same colossal vortex first observed by Cassini in 1665. Instead, the original storm might have died out long ago, replaced by a younger, newly formed vortex that inherited its place in the spotlight. If that is true, then the real Great Dark Spot is not a mysterious shadow hiding in Jupiter's clouds, but the silent disappearance of a storm that once dominated the planet's atmosphere for centuries. And the surprises do not stop there. High above Jupiter's cloud tops, Scientists have discovered an enormous region known as the Great Cold Spot, a frigid imprint in the thermosphere where temperatures plunge nearly 200 Kelvin below their surroundings. It drifts near the planet's northern auroral zones and changes shape over time, hinting at a level of atmospheric complexity far beyond what most people imagine when they picture a gas giant together. These clues paint a picture that is more dramatic and more haunting than any headline suggests. We may be witnessing the slow fading of a storm that once towered over Jupiter like a planetary monument, and the emergence of new, darker atmospheric structures that reveal the hidden machinery of the planet's climate. In Section 7, we will explore the astonishing consequences of this possibility, from what it means for Jupiter's future to what it teaches us about the fragile systems of our own world. The shrinking, pulsing and possible disappearance of the Great Red Spot forces us to confront a question we were never prepared to ask: why would a storm large enough to swallow Earth ever fade at all, for decades? Scientists believed that Jupiter's monstrous tempests were almost eternal, fueled by endless jet streams, deep convection currents, and the absence of any solid surface that could slow them down the way mountains and continents do on Earth. That stability should have allowed the Great Red Spot to persist indefinitely. An immortal monument carved into a planet made of storms, but if a vortex of that magnitude can weaken, transform, or die, then the atmospheric engines inside gas giants are far more dynamic than we assumed. The implications reach well beyond Jupiter. A vanishing storm on one gas giant forces us to reconsider the weather systems of all gas giants, from Saturn to the distant exoplanets orbiting other stars. If their storms can be born, evolve and disappear on cosmic timelines, then their climates may be far more complex, unstable or alive than our simplified models suggest. And hidden behind that realization is one final message, directed not at Jupiter but at us. Earth's atmosphere, with all its familiar patterns and predictable cycles, may also be more fragile and more easily shifted than we like to believe. Nothing in a planetary climate is guaranteed to last forever. Not even something as legendary as the Great Red Spot. Stay tuned for Section 8, where we uncover unreported data and a mysterious dark feature NASA has almost never mentioned. Hidden in the fine print of Jupiter's research is a collection of findings that almost never reach the public eye. One of the most striking is the 90-day oscillation of the Great Red Spot, a rhythmic swelling and thinning uncovered through Hubble data and mentioned briefly in scientific reports, but rarely followed up or highlighted in mainstream coverage. It is the kind of discovery that should reshape our understanding of Jupiter's atmosphere. Yet it slipped quietly past headlines and vanished into the noise. The same silence surrounds the Great Cold Spot, a vast dark imprint in Jupiter's thermosphere, where temperatures drop nearly 200 Kelvin below their surroundings. Despite its scale and significance, it is barely mentioned outside specialized journals. Even though it shifts shape, drifts across the poles, and hints at a hidden layer of atmospheric physics still waiting to be understood. And these two anomalies lead to a deeper question, one that is almost never asked: if we have already missed features this large and this strange, how many more dark regions, faint vortices or hidden atmospheric structures could be escaping our detection simply because our instruments catch only certain angles and certain wavelengths? And if such features exist, what would they mean for our understanding of Jupiter's climate, its energy flow, and its long-term evolution? These unanswered questions form the true shadow behind Jupiter's beauty. In Section 9, we will bring all of this together and end with a question that belongs not just to astronomers, but to our entire generation, and a call to action meant for you. If you step outside on a clear night and look toward the part of the sky where Jupiter glows, it is hard not to feel a quiet sense of awe. Somewhere inside that bright point, a storm larger than our entire planet is turning, pulsing, and perhaps slowly fading. For centuries, it has been a symbol of power, a swirling monument of color and motion that feels almost eternal. Yet now, when we imagine it, the image changes. The deep reds and towering clouds begin to soften. The mighty vortex that once dominated Jupiter's face starts to feel fragile, like a giant taking its final breaths. The cinematic grandeur of it all becomes impossible to ignore. The scale, the colors, the sheer energy, and beneath it, a silence that grows a little louder each year. And there is a lesson hidden inside that silence. Just as interstellar travelers like 3I Atlas remind us that the universe is full of wanderers that appear briefly before slipping back into the dark, Jupiter's storm teaches us that even the most iconic phenomena are not guaranteed to last forever. Great things can vanish, familiar patterns can break, and sometimes the most important truths are the ones quietly disappearing before our eyes. And now comes the final question. Are we witnessing the end of an era or the beginning of a brand new chapter in planetary weather? Stay with me for the final reveal. From the famous red storm to the quiet shadows hidden beneath it, we've traveled through the parts of Jupiter. The news rarely lingers on the changes, the mysteries, and the quietly disappearing truths that shape the planet's atmosphere. And now we're left with a question that reaches beyond Jupiter itself. If a storm can live for centuries and then fade softly out of existence, what does that say about the storms on our own world? Or about the cosmic patterns we take for granted as permanent? The universe has always whispered its warnings and its wonders to those willing to listen. So, as we close this chapter, take a moment to hold on to the message at the heart of this journey. Stay curious. Stay critical. Are you ready to listen? And before you go, tell me in the comments what other silent phenomena in space should we uncover next. If you want to keep exploring the unseen, the overlooked, and the extraordinary stories hiding behind the headlines, make sure to subscribe and join us for the next journey into the parts of the universe most people never see.